8.6, Formula for the area of a parallelogram. The objective? To review the properties of parallelograms and to guide the development and use of a formula for the area of a parallelogram. Let's start first with some mental math and reflexes. See if you can beat the teacher on your answers. I will give you a second or two to try to come up with them since I know them a little quicker, normally. 3 times 7, 21. 4 times 9, 36. 8 times 5, 40. 9 times 6, 54. 9 times 8, well 8 times 9 is 72 plus 1 0 is 720. 10 times 90, 900. 60 times 70, 4,200. And 80 times 30, 2,400. Remember, you can take the first number of each set of numbers, multiply them, and then just add the amount of zeros that you have. So you had 1 behind the 8 and 80 and 1 behind the 3 and 30. So you had to add 2 zeros onto the end of your answer. 8 times 52, 416. 63 times 4, 252. 9 times 76, 684. And 88 times 5, 440. Keep practicing those multiplication facts. Math message. You're going to take 2 short straws, 2 long straws, and 4 twist ties. So I want you to think, what do you know about parallelograms? Using your straw constructions as models, list the properties that you see. They should include: a parallelogram is a 4-sided polygon, and it's called a quadrangle or a quadrilateral. Opposite sides of the parallelogram are parallel. Opposite sides of a parallelogram are the same length. Rectangles and squares are special kinds of parallelograms. I want you to form a rectangle with your straw constructions, and then pull gently on the opposite corners. You should get a parallelogram that is not a rectangle. Then I want you to see, does the perimeter remain the same? Remember, perimeter is around the outside. Does that remain the same? Yes, it does. Does the area remain the same? Hopefully you notice that no, because although the length of the base stays the same, the height decreases, so the area decreases. So take a look at the parallelogram below in this first box. The base means the length. So when you're looking here, you can see the word base here. And sorry about that. The base here is its length. Alright? The height is what goes from the top to the bottom. Just think of height as how tall you are. When they measure your height, you are standing straight up and down. So that's how you can remember height. Any side of a parallelogram can be the base. The choice of the base determines the height. So the shortest distance between the base and the side opposite the base is called the height of the parallelogram. A dashed line is to show you the height, and that's what it's showing you in all 3 here. This is considered the height, where it's dashed. This could be considered the height, or this way is considered the height. The dashed line can be drawn anywhere between the 2 sides as long as it is perpendicular. It forms a right angle with the base. And here's your right angle symbol that is showing you that it's forming a right angle. Remember, students, rectangles are parallelograms whose sides form right angles. If you think of one side of the rectangle as its base, then the length of an adjacent side is its height. So you need to look at Math Journal page 236 and the Math Masters page 260. You need to follow the instructions on this page. You need to cut out the parallelogram A from the master. You need to cut the parallelogram into two pieces along one of the vertical grid lines, and you need to tape those pieces together to form a rectangle. Okay, tape this rectangle in the space next to the parallelogram in the journal, and I want you to think about the relationship between the parallelogram and the rectangle formed from the parallelogram. And then look at the questions below and the answers that go with it. So again, the length of the base of the parallelogram is equal to the length of the base of the rectangle. The height of the parallelogram is equal to the width of that rectangle. Therefore, the area of a parallelogram is equal to the length of its base times its height. So using variables A for area equals B, base, times H, height, where B is the length of the base and H is the height. Record this formula at the bottom of your journal, page 237. If this seems a little unclear, look at the pictures below. It's just showing you that the base is the 6 centimeters and the height is the 2 centimeters. That's what we use for area. We do not use the 2.2 that's on the outside. We use what's inside. The outside numbers are for perimeter. On the next one, again, it's just showing you if you change it and have a straight rectangle, it's 2 centimeters. So look, it did change slightly by not having a regular straight up and down rectangle, and it became a parallelogram. Solving area problems. You need to go to Math Journal page 238 and complete that page, and then go up to the Student Journal answer key and correct your answers. Again, remember that in problem 7 it illustrates the fact that shapes that do not look the same can have the same area. Alright, so if the rectangle covers 12 grid squares, if one triangle were cut apart and placed next to the other triangle to form a rectangle, the pair would cover 6 squares. The rectangle and two triangles covered 12 plus 6, which equals 18 centimeter squares. And then in problem 8, again, it can be solved without using a formula for the area of a triangle. The parallelogram area minus the trapezoid area is the triangle area, which is 24 minus 18, which equals 6 centimeters squared. Go ahead and do your math boxes. Remember to look into your SRB first if you're struggling with any concept that you're trying to do a review skill on. And if you don't understand one, come back to me and I will help you. When you finish this page, please go up and check it. And the final thing to do in 8.6 is to do the study link, which works with areas of parallelograms. Make sure to finish the entire page and then turn it in so I can see how well you've mastered this skill.